in this section. So 3 kinds. We're in 3.4. The whole section is word problems. We're going to cover 3 kinds of word problems. The first is money. You can tell it's clearly got money involved. The college paid $1938 for, you don't need to write all those words out. I would just write out 1938 for 50, my 5 is looking a little funny, for 50 calculators, and $9 for each scientific, and the graphing were 57 each, so $57 each for the graphing calculators. Okay, how many of each type did they use? Okay, so that's the question. They spent $1,938 buying for the bookstore, for the college or whatever, 50 calculators. They bought some scientific, some graphing. Everybody getting the deal? They bought some cheap ones, the scientific kind. They bought some more expensive ones, the graphing kind. Somehow, altogether, it came out to be $1,938 for 50 calculators. So how many of each type did they buy? Did they buy like 40 scientific and 10 graphing? Or did they buy 30 scientific and 20 graphing? Or what did they do that totaled $1938 for 50 calculators? So how do we figure that out? So that's the money question. So how we do the money questions, so this is the first type. Like I said, 3 kinds of word problems. Money is the first type. Is you want to separate the money from the non-money. That's the big deal. You want to be really clear when you're talking about the equations in a money problem. What has to do with money and what does not have to do with money? Now that sounds like fun. Like, what do you mean doesn't have to do with money? Well, think about this for a minute. What if I said, hey, I want to tell you about $10 bills. $10 bills in my wallet. $10 bills. All right, I'm going to tell you about $10 bills. You ready? 50. Now, if I was you, I'd be thinking, what do you mean 50? It's bad communication. You mean you got 50 $10 bills, Mr. Aaron? Or do you mean you got $50 in $10 bills? That'd just be 5 of them. That's quite different. What does that 50 thing mean? Is it 50 of them or $50? Right, that's the issue. That's what we got to be really clear about. When you're talking about items of value, money problem, things that have monetary worth, you want to be really, really clear whether you're talking about dollars, $50 in $10 bills, or number of objects, 50 $10 bills. That'd be $500, right? Very, very different. And that's what you got to be clear about when you're doing these word problems. That's why the way the method works is you're going to have one equation number 1, that's going to have nothing to do with money. It's going to treat them just like objects, just how many of them. So I'm going to say scientific calculators plus graphing. You could use X and Y, but I think it's easier to use meaningful letters. Scientific plus graphing equals 50. That's just treating them like objects. That's not considering their worth, their value, their monetary value. So, right? The first equation, no money. Do you see how I didn't use money anywhere? There's no money here, no money here, and no money there. 50 is just how many of them, having nothing to do with their value so far. So the first equation in a money word problem, the first equation is no money, no money, no money. Just like that, straight across. In the second equation, it's all about money. Now I'm going to put the money next to each of them. How much are the scientific calculators worth? $9. Whoops, I'm erasing it. $9 each. It's 9 times S. Because however many scientific calculators the bookstore ordered, times $9 each will give you the money they paid for all those scientific calculators, right? Plus 57 times G, because the graphing calculators were $57 each, so they paid $57 for each graphing calculator times, G is how many graphing calculators they bought, times $57 each. That'll give you the money they spent on all the graphing calculators. That adds up to be what? 19. The 1938, because that's the total money they spent for all the calculators. Does that make sense? See how that second equation has money, money, and money in it? It's all money, isn't it? So the first equation is no money, no money, no money. The second equation is money, money, money. So it's all about separating out the no money from the money. So there we have 2 equations with 2 letters. When you have 2 equations, you need 2 letters, or vice versa, 2 letters, you need 2 equations. So you guys are pros now at solving 2 equations with 2 letters, right? You could do it in your sleep. What do we do to solve these 2 equations now? Yeah, make the fronts opposites, huh? Let's just make the fronts opposites. So what I'm going to do is I'm going to multiply the top one by -9, right? -9, -9, -9, all the way through the top equation. -9s plus -9g, -450. The bottom one is 9s plus 57g, 1938. Add them up. Boom. This is 48g. I don't know what that is. Somebody have that? 14 something? 1488? Thank you. 1488. Let me slow down there. Is everybody okay with what I'm doing? You see what's happening there? Does that make sense?
Yeah.
And then just divide by the 48, right? Divide by the 48. And so G, what's that number?
31.
What is it?
31.
31, thank you. So they must have bought 31 graphing calculators. And now we just plug that in. Or actually, you know what the easy thing to do on these all these money ones? Yeah, they bought 50 total, huh? 50 total calculators. So just subtract from 50. Because you know there were 50 total calculators. What's that, 19? 19 scientific calculators. They must have bought 19 scientific and 31 graphing. And we're done. All right, so let me run over one more time. So on a money problem, you've always got 2 equations. The first equation is always no money, no money, no money. Nothing to just treat them like objects. Just number of scientific plus number of graphing is 50 total objects, right? The second equation, you bring the money in. $9 times however many scientific each, $9 each, times $57 each times how many graphing is the total money, 1938. That's money, 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 all the way across on the second equation. And then just make the fronts opposites, do the usual thing. Questions on that? So that's money. Nothing special. Okay. So let me write out the key facts for you. 33 sweatshirts. The white, we'll write them up here. The white sweatshirts are $9.95 each. The yellow ones are $11.50 each. There was $3.57. Make that a little better. $3.57.80. And how many were sold? Oh, 33. Yeah, $3.57.80 and 33 were sold. There we go. Yeah. Okay. Okay. Give that a try. They want to know how many yellow and how many white sweatshirts were sold, just like the one we just did with the graphing calculators and scientific. So you read a money problem, you think, okay, 2 equations. First equation, no money. Second equation, it's all about money. Doing okay? So that the top equation would be white sweatshirts plus yellow sweatshirts. And then how do you know what number I'm going to put? Yeah, what number has, remember the first equation is no money? Which one of those numbers has nothing to do with money? Doesn't have a dollar sign. Yeah, the 33, huh? It's the only one without a dollar sign. So that's got to be in the top equation because there's no money in the top equation, right? That good? Then the second equation, just put the money in there. So you bring in the money. The white sweatshirts are $9.95 each. The yellow sweatshirts are $11.50 each. And the total money is $357.80. Is that good? All right, you know what to do now, right? These kids are going to be ugly decimals, but make the fronts opposites, right? So we'll just multiply the top equation by minus 995, minus 995, and minus 995. Good? Minus 995W, minus 995Y. And then I have no idea what is 33 times like minus 300 and something. 328.35. Okay, thank you. And then the bottom equation, it didn't change at all. Add them up, boom. What is this, is it 155? I think. And then over there, 29.45? Thank you. 29.45. We doing okay? Is that making sense? What's happening there? And then divide by the 1.55. And y equals, what is it?
19.
Is it 19? Just a clean 19? It's always nice when that's a whole number, right? After all those decimals. That's a sign that you're on the right track. Because you can't have part of a yellow sweatshirt. Can't sell 19 and a half yellow sweatshirts, right? It's got to be a clean, whole number. When I was working to get my master's degree at Cal Poly, I had to take a really, really, really hard test, and you could fail it twice, and if you failed it twice, you could never get a master's degree in math at Cal Poly. Never. That was a new rule they made my year. They give this exam twice, and if you fail it twice, it's bye-bye, don't ever come again. Literally ever. Lifetime. You may not get, they don't want you. So I failed it the first time. So I'm like, oh. So I'm down to one try now. So anyway, I remember they offered it once every 3 months. It was kind of a big deal. You came to a special building and da-da-da-da. Anyway, but I was taking it the second, and was my last time either way. And my answers were coming out clean. And I was like, oh, I'm going to pass. That's got to be right. I mean, it came out clean. That's got it. And it was. I did pass the second time. But anyway, yeah, so it's reassuring when the answers come out clean after all those decimals in the middle of the test. You know you're probably on the right track. So y is 19. And then what do we do to find the other letter? Just subtract from the total. Right, total is 33 there. Total is 33. So just subtract from 33. So you just take 33, subtract the 19. What's that? 14? 14. So that's the other one. What is it? W? That's W. You can always just subtract at the end because you have the total amount of the two things. So there we go. Is that good? Questions on that? All right, good. All right. So that's the first kind. We're going to do 3 kind of word problems in this section. We're on good time track. So the first kind is money problems. So there. Okay, so here come the mixture. So soybean is 14%. 14% protein. Well, yeah. Yeah, it's all percent, huh? So this is the soybean stuff. Soybean is 14% protein. Cornmeal, I'm not going to write protein. It's all about protein. Cornmeal is 7% protein. And you want to get a 280-pound mixture. That the goal, the desire, the goal is to get 280-pound mixture that is 8% protein. Yeah, so we want to mix a couple of things and produce a final product that's 8% protein. All right, so it's a mixture problem, like chemistry, if you take chemistry. So let's lay that out. I'm going to do the totally standard method that everybody does.
I forgot the cups.
I think it's a good method. So beakers, boxes, whatever you want to call them. Looks like chemistry lab with some beakers. So we're combining 2 things to equal a final thing. Combining 2 things. So this one's the mixture over here, right? You with me? We're combining 2 things to produce a final product. And so what we do first off is we put the percentages in the bottom and the amounts will go in the top. So I'm going to go 14%, 7%, and 8%. So I put the percentages in the bottom. If you've taken Math 201, you've seen this. This is review yet again. I think we did money and mixture back then too.
Yes.
So you get real comfortable with these things after a while. If it's new, then it's not so comfortable right now. So write the percentages on the bottom. And then in the tops, we put the amounts. Now, they only gave me one other number. I've used the 14, used the 7, used the 8%. The only other number is the 280. How do you know where the 280 goes? Well, it's just whatever they're saying. What are they saying? It's the 280-pound mixture, so it's over here. But sometimes they will have it be in the middle or the left. You just have to, they'll tell you. They'll say it's 280 pounds of the 7%. So if they say that, you put it with the 7%. If they say 280 pounds of the 14%, well, then you put it with, whatever. They'll tell you. They're saying 280 pounds of the mixture, right? So I put it over here with the 8% mixture, since that's what they're saying. Okay, I've got 2 blanks. What do you think goes in those 2 blanks? My X and my Y, or whatever letters you want to use. Yeah, that's where your X and your Y go. Okay, so now that's our picture, but we've got 2 letters, and so whenever you have 2 letters, you've got to have 2 equations. So in a minute, we're going to do travel, like cars and trains and stuff, and those we're only going to have 1 letter and only have X. We won't have X and Y. We'll just have X, and so we will only need 1 equation. If you've only got 1 letter, you only need 1 equation. Those are a little easier. If you have 2 letters, you need 2 equations. So we need 2 equations. How am I going to get my 2 equations? Well, the first one comes across just take the tops. So right here, just go right across the tops. X plus Y equals 280. Good so far? That's just total amount of stuff is all that equation means. However much stuff is coming out of the first beaker, plus, and remember the top is amounts, plus whatever amount is the second, however much soybean, however many, what is it, pounds? Pounds? Yeah, how many pounds of soybean, plus however many pounds of cornmeal has got to be 280 total pounds, right? We're just adding them up. Now, the second equation you get by multiplying. So I multiply 14 times, so make it a decimal, 0.14x, multiply 7% times y, which would be 0.07y, and multiply 0.08 times 280. So that was multiply, multiply, multiply. Did you track with all that? So the first equation is top, 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 because it's just amount. Second equation is multiply, multiply, multiply. Now let me say two things about this second equation. First thing is, we can get rid of all those decimals. We don't need them. We could just multiply through by 100, couldn't we? And it would move all the decimals 2 places, 2 places, and 2 places. So let's just skip the whole thing from now on, just to make these easier. You see what I'm saying? Because we have decimals all the way across both sides of the equal sign, and we can just multiply both sides by 100. Well, it'll just move them all 2 places. So why don't we just skip the whole thing from now on? Here's what I mean. When you actually do these mixture problems, just go 14x. Don't even make it 14. Make it 7y. Don't make it 0.07. Make it 8 times 280. Don't make it 0.08, because you could just get rid of them anyway with 100. So let's just skip it. So we'll just take them as straight whole numbers, not decimals, because we could get rid of them anyway by multiplying by 100. That's the first thing I want to say. Second thing is I want to say, what is it? Why are we allowed to multiply? What in the real world allows us to do that? We're actually getting amount of protein is what we're getting. You know, that soybean, however many pounds of soybean, it's 14% protein. It's 14% protein. That means however much soybean you have, 14% of it is protein. So, for example, if I had 100 pounds of soybean, if I had 100 pounds of soybean and 14% of it was protein, I would need to multiply by 0.14 to find out how much actual protein. That would come out to be 14 pounds of actual protein. So when you multiply, you find the actual amount of protein. So when I take 0.14, which originally was 0.14, right? 0.14 times x, that's actual protein coming out of all the soybean pounds. And this is actual protein coming out of all the cornmeal pounds. And this is actual protein in the final mixture, because it's the percent protein of the final mixture. So you're adding up protein out of the first bag plus protein out of the second to equal final protein. That's what you're really doing. All right, anyway, there's the real life reason. Let's get back to solving. Somebody have the calculator. What is that 8 times 2? What is this right here? 2240? 2240. All right, so now you know what to do, right? 2 equations, 2 letters. Make the fronts opposites. Just make those fronts opposites. So I'll multiply through the top equation by minus 14. We've done this a few times now. Right on through by minus 14. In fact, I'm going to go to a fresh screen, I think. So we got x plus y is 280. So and the other one was 14x plus 7y equals 8 times 280, 20, 240 times 280. And we're multiplying the top equation by minus 14. Like that. And we get minus 14x minus 14y and what's up? 14 times 280?
We should ignore the decimals when it comes to that, right?
Yeah, we ignored all the decimals.
I wasn't paying attention. I'm sorry.
We can ignore all the decimals. 14 times 280? 30 what? 3920. Thank you. Second equation. Like that. Let's use your calculator. You use calculators, all this stuff. What do you get? Minus 7y is minus 1680. Is that right? Yeah. Then divide by minus 7. I'm hoping it's clean. 240. That's always a good sign when it's clean. 240. We're probably getting it right. 240. So that's y. And now to get x, to find x, you could just plug in, or you could just subtract from 280. Remember, 280 is the total. You could just do that. So 280 minus 240 leaves 40. So y must be 40. Same thing as plugging in. If you plugged in, you'd get the same answer. So y is 40. X is 40, yeah. X is 40. And now which one, what they'll ask you, they won't say what's X and what's Y. They'll say how much, how much soybean and how much cornmeal. How do we know which one of those is soybean and which one of those is cornmeal? Yeah, if you go back, I put the soybean is 14%, I put X. I happen to put X with the 14% soybean. So X represents soybean. I could have done it vice versa, but I happen to put X with the soybean. So this is soybean, and the other one is cornmeal. Just based on how I did that. Is that making sense then? Questions on that? Mixture. This is the second kind of word problem. So we had the money, and now we have the mixture. So again, the mixture, you just make the 3 beakers or buckets or whatever, put the amounts, we'll put the percentages in the bottom first, and put the amounts in the tops, and then the first equation comes from top, the second comes from multiply, the rest is the same. No questions, all good? Shall we try? Okay. So orange, 1 canned juice drink is 50% orange juice. So the first kind is 15%. And the other is 10%. How many liters of each should be mixed together to get 5 liters of 11% OJ? So that's the plan. So we're mixing some 15% OJ and some 10% OJ. Kind of mixture, it's 5 liters of 11%. Abraham.
What was that with the bottom mixture, the highest and the...
Yeah, let me come back to that. I understand. I'm saving that. Yeah, just a second. So just set up the basic. Just try the basic on that. But that's a good question. I do want to mention that in just a minute. So if I forget by the end of the day, remind me again. But yeah, let me wait on that a little bit. So try that out and see what you can do. 3 beakers. Set that up.
After you do multiply, the decimals disappear. Right?
Yeah, right. Y'all doing okay? Is it making sense? So we're going to do the 3 beakers. And put the percentages in the bottom. And 15%, 10%, and 11. And then in the tops, they're only giving me one other number, right? They're giving me the 5 liters of the 11%, so that does go right there. This will be the X and the Y, or you can call them whatever you want, like that. Good. That's the amounts in the top. And then we got to get our equation. So the first equation, how do we get our first equation? It's right across the tops. So X plus Y is 5. Top. The second equation comes from multiply. And I don't need to mess around with decimals, huh? We just skip it because we could get rid of them anyway by multiplying by 100. So we just skip the whole decimal thing, and we just go 15x plus 10y and 11 times 5. And you just go ahead and make that 55. Is that okay to there? Is that making sense? So the first equation is top. The second is multiply, isn't it? These two right here? Yeah, so good question. So, is everybody seeing how I'm getting that second equation? I'm multiplying 15 times x, huh? And multiplying 10 times y, and multiplying 5 times 11. See how it's consistent multiplication on that? I'm multiplying. It's just the first two happen to be letters, so it's just a number times a letter, and a number times a letter, but this is number times number. Everybody good there? We see how I'm getting those two equations? Okay. And now just make those fronts opposites, like usual. That good to there? Just make those fronts opposites. Just multiply through. Whoops, get a little sloppy there. Multiply through by negative 15. Like that. So negative 75. Good to there. Add them up. X's cancel. Minus 5y. What is that? Minus 20. Minus 5y is minus 20 divided by minus 5. Y is 4. We good to there? How we doing? Are we still happy? Are we still having fun? Have we been having fun? I'm assuming if it's making sense, it'll be more fun. So is that making sense? So y is 4. How do we get the other one? You can plug in or just subtract from 5. It's got to be 1. But if you want to be more formal about it, you can just plug in. You can always do that. You're always allowed to just plug in. I just give you some shortcuts sometimes. So you can just plug in. Y is 4. Plug in where? Top equation. Top equation is always the easiest on the money and the mixture. Totally. Just grab that top one. He's a real simple one. X plus y is 5. Just plug in the 4. X plus 4 is 5. See how it ends up just being subtraction anyway? You could have just subtracted it yourself. That's fine. Either way. So X is 1. So there we go. Now, if they're going to say, how much, what's their actual question? Here's the question. How many liters of the 15% oranges? Well, the 15% is the X. So 1. Yeah, everybody see that? So the first answer would be 1, and the other answer's 4. So they should mix 1 liter of the 15% stuff plus 4 liters of the 10% stuff to get 5 liters of the 11% stuff. That's what they should do. Is that good? On that? Questions on that one? So we've had 2 money problems, 2 mixture problems. We need to go to the last type. Before I do want to point, Abraham's question was a good one, or his reminder was a good one. Let me come back here. Sometimes they're more tricky. They try to be more tricky with the percentages, and they'll kind of try to mix them up in the word order. The 2 we did were pretty straight ahead. But what I mean is sometimes they'll, instead of just saying 15%, 10%, and then you want your mixture to be 11%, and we just kind of directly put them in order, just 15, 10, 11. Sometimes they'll be more tricky, and they'll say like the 11%. They'll go, we want a mixture to become 11%. So how much of this, they'll kind of rearrange it. If they do, the way you can keep from getting fooled is just to notice that, remember, the one on the right is the final. This is the mixture one, right? That's the final product, the result. It's got to be the mid-level, doesn't it? In other words, something stronger and something weaker have to mix together to produce a final thing that's between them, mid-level strength, doesn't it? That has to be. So no matter what order, if they give you 3 percentages, no matter how fancy they try to say it, you can just grab the one in the middle, and that's got to be the right side. Let me try that. What if they gave, let me be real clear here. What if they gave you, I don't know, 16%, 29%, and 18%. Okay, what's the highest percentage there? There's that high. Who's the lowest? So who's the mid-level? 18. That means when you set up your beakers, the 18's got to go here. Because why? Because he's mid-level. So the stronger stuff and the weaker stuff, and you can put these in, or you put 16 here, 29 there, you put 29 here, and 16. It doesn't matter at all. First two, the order doesn't matter. Who cares? But the final one has got to be the mid-level. Like you could not put the 29 over here or the 16 over here, right? You got to have something stronger and something weaker producing something in between them. So the final mixture has got to be the mid-level percentage, doesn't it? No matter how they try to trick you in their word order. We good on that? So watch for their trick order ones. All right, last kind, travel. Travel word problems. So we got cars and trains and motorcycles and stuff. So two motorcycles travel toward each other from cities that are about 320 kilometers apart. So just all you need to write is travel towards each other, cities 320 kilometers apart. I'm going to write this over here, apart. Those are the key facts. And then, and their speeds. Their speeds are 95 kilometers per hour and 65 kilometers per hour. They start at the same time. And the question is, how many hours until they meet? How many hours till they meet? So we have like a motorcycle starting way over here and a motorcycle starting way over here, and they're going to travel. One's a little faster than the other, so they're not going to meet exactly in the middle. Right? They're going to meet somewhere in the middle. So the two motorcycles traveling towards each other, they're going to meet somewhere in the middle. What formula, I'm really scribbling up there. Can you read all that? What formula do we always use when we do travel? Yeah, distance. Have you seen that before from physics? Distance equals rate times time. Distance equals rate times time. And what I'm going to do, we have two motorcycles. We're always going to have two travel situations. So I'm going to put two boxes under each of these letters. So there's two boxes under D, two boxes under R, and two boxes under T. And they're going to be just for the two motorcycles. So I'm going to have like motorcycle number 1 over here and motorcycle number 2. And I have the distance, the rate, and the time for each of those. So let's make sure we're clear on that. Like what I'm going to just throw in some numbers before we get to the actual solving. Like what if we put a 10 there? What would that mean real life if there was a 10 in that box? That would be motorcycle number 1's distance. So like maybe 10, we're talking kilometers in this one, right? The motorcycle went 10 kilometers. That's what that would mean if there was a 10 in that box. What if there was a 10 down here in this box? That'd mean motorcycle number 2 went 10 kilometers, right? It's a distance for motorcycle number 2. What if there was a 10 in that box? What would that mean if there was a 10 in that box? That's the rate. What is rate? Rate is speed, right? That's the speed. That would mean the rate of motorcycle number 1 was 10 kilometers an hour, like 10 miles an hour, but kilometers. If the 10 was down here, that would be the rate of motorcycle number 2, speed. What if the 10 was over there? What would the 10 there mean? 10 hours. That'd be time, huh? That'd be time. And motorcycle number 1 traveled for 10 hours. Right, so you get it. You get what the boxes are doing. Okay. So with these boxes now, well, the way it works, which ones are we going to get? We're going to get 4 boxes from the words. So we're going to get 4 boxes from the words. And then the front, so that's step number 1. Step number 2, the front 2 boxes come from multiplying. D equals R times T. You just multiply. Okay, so let's try that. So what they're saying 95 kilometers per hour. Is that a distance, a rate, or a time? That's the rate. That's the speed, huh? So I'll put that down as the rate for motorcycle number 1. Okay, next, 65 kilometers per hour. Another rate, that'd be the rate for motorcycle 2. Okay, now, what do we do with that 320? 320 kilometers. Is that a distance, a rate, or a time? That's a distance, isn't it? But it's not either motorcycle's distance alone. Do you see that? I'm not allowed to put the 320. I mean, it's just not true to put the 320, because if you put the 320 in there, you would be saying that motorcycle number 1 traveled 320 kilometers. That's not what the words are saying, huh? They're saying the two motorcycles started out. They traveled until they met, but they started out 320 apart. Neither one of them covered the whole 320. They both covered part of the 320. Together, that's the big hint. Together, they covered the 320. Right? One went most of the way, one went a little less than half the way because it was slower. And together they covered the whole 320, but neither one did it alone. So we can't put the 320 in either box. It's not true. Neither one did. Where's it go? Well, you could put it down here if you want. You don't have to put it anywhere. It doesn't really go on the table. But I'll put it down there to remind us they're going to add up to be the 320. They're going to together cover the 320. Does that make sense? Let's go on. We still need 4 boxes. I've only got 2. Here's the other key. I don't know why I put a plural on that. Same time. The 2 motorcycles left at the same time. So that means they traveled the same amount of time, right? They left, the motorcycles left at the same time. So that means, I don't know how long they traveled. I have no idea. But I know whatever it is, it's the same. So what can I do for these 2 boxes to make them the same without knowing what they are? They're both X, huh? That makes sense? I don't know what they are, but they're both the same. Now, in some of the other word problems, it'll say, one of the motorcycles left 3 hours earlier. Well, then he would have 3 more hours of travel time, wouldn't he? Things like that will happen in the other word problems. They won't be the same time. One will go earlier or later than the other. But in this case, they're both the same time. They're both just X. Now, I've got 4 boxes. That's step number 1. Get 4 boxes from the words. Check. We got it. Step number 2. How do you get the front 2 boxes? You multiply. Yeah, it's the relationship. Distance equals rate times time.
95x.
Yeah, 95x and 65x. Does that make sense? I just take 95 times x, 65 times x. Distance equals rate times time. And then, do you see where our equation is going to come from? Right there. They have to add up. Why? What am I talking about? Because however far motorcycle 1 went, 95x. And right, that's the distance for motorcycle 1. And however far motorcycle 2 went, 65x. They have to add up to be the whole 320, don't they? They cover the 320. So you add them up. So I kind of out of room here. Let me come up here. So that's our equation, and that's not a hard one to solve. Easier than all those other ones we're doing today. So that'll be a 95x plus 65x is 320. There it is. You can read that up there. 320. And then what is that? 150. 160x is 320. Last step to solve. Divide by 160. X is 2. So that's it. 2 hours. They were on the road for 2 hours. So that's easier solving. Yeah, remember how I said they'd only have 1 letter? See, we only have X, so I don't need 2 equations, do I? I just need the 1 equation because I've only got the 1 letter. Is that good? Questions I can answer on that? Ready to try one of those? So I had a student years ago, a lot of years ago, like 20-something years ago, said, the dirt equation, Mr. You mean the dirt? Sure, that works. That helps you remember. It's like the word dirt, right? It's like an I there. So the dirt, the distance, rate, time equation. What do? You get 4 boxes from the words. The front 2 come by multiplying, and then you write an equation using those front 2. Okay. Almost too easy. It's exactly the same, basically. All right, so 2 planes. Can you read all that? So 2 planes planes travel towards each other from cities 29.75 kilometers apart. The rates are 440 kilometers per hour and 410 kilometers per hour, same time. So this is very, very similar. Give it a try. It's almost exactly the same. How many hours will they meet? So try the dirt equation, distance equals rate times time. Set that up. All right, we're doing good. So, what do you do with the 29.75? Yeah, that's the bottom. That's, it's not. It's the total distance, right? Again, the two planes start off. They're going to travel. They're going to meet in the middle, and the total distance is 29.75. It's not either distance alone. So the rates are 440 and 410, and the times are the same. So x and x. So we go 440x. 410x, add these up, just exactly like the last one, verbatim. So we go, okay, 440x plus 410x is the total distance, 29.75, easy enough, right? 850x, 29.75 divided by 850, is that like 3.5? Yeah. 3.5? So 3.5 hours, 3.5 hours, they will meet. Good, easy. They're going to get a lot more tricky than that. So you're ready? I want to give you the basic one, and we'll back up to the tricky one. So good with that? All good? So remember the basic game plan. When they get more tricky, it's still the fundamental. We started with the easy. Okay, so number 8 now. So it says one town to another. Okay, car travels one town to another. So car travels between towns at 42 miles an hour. If it had gone 14 miles per hour faster, it could have made the trip in a half hour less time. How far apart are the towns? Okay. Can you read all my writing? Let me know if you can't read something. So, okay. All right, give it a try. Rather than me just whipping it out, I think you get more out of it. Even if you don't get it right, you'll gain more knowledge if you try. So give it a try. Set up the dirt. 6 boxes, You got to get 4 boxes from the word. See what you can get. part of the trick on this one. There's really not like a car number 1 and a car number 2, or what there's just one car. I mean, so what do we do? Why do we have 2 rows? We're always going to have 2 rows. Why? So what are the 2 different? Like, it's not 2 different cars. What are the different things? It's the same. It's the same town. It's just this car. See if maybe I should try to make more sense of it for you. It's just this one car, and he's just traveling between 2 towns, and he's saying, "Hey, if I'd gone faster, I could have made it quicker." That's what he's saying, right? If I had just driven 14 miles an hour faster, I could have made the trip in a half hour less time. So it's the same 2 towns. It's the same distance, right? But it's just making the trip quicker. So there's it's the trip he took, and then if he'd gone faster. So there's not really 2 different cars. There's just the trip and then faster. If he'd gone faster, right? It's not like a different car. It's just a different trip if he'd gone faster. All right, so take it from there. See what you can get. All right, hey, you guys do anybody got any thoughts? Okay, we're going to do with the 42. Let's start there. Is that distance, rate, or time? That's a rate. That's a speed, right? Miles per hour. So that's how fast he made the trip. He did travel at 42. He went slow. That's why he's thinking, I should have gone faster, right? He went at 42 miles an hour. Okay. Now, do I know the other rate?
42 plus 14.
Yeah, if he'd gone 14 faster. If I said, hey, I went 42. Well, I went 14 faster than that. What's that? 56? Yeah. He's saying if I'd gone 56, right? That's right. 42 plus 14. He's saying if I had gone 56 miles an hour. You with me? That's the second rate, isn't it? 14 faster. Good. Now, what about the time? What do you do for the, now, is it X and X like it was in the other ones? Almost, not quite. It's X and what? Yeah, it's a half hour. Whoops, half hour less time. So what does less mean? Subtract, doesn't it? Doesn't less mean subtract? So one of them's X, and the other is X take away. I'm going to use 0.5. It's easier than a fraction. I think decimals be easier. Let's use decimal. That's half, right? Does that make sense? Less time, subtract. Now, how do you know which one gets the X and which one gets the X minus 0.5? Yeah, faster trip, lower time. Makes sense. So less time is on the faster trip. That's why we drive faster. So think less time, right? Good? Is that making sense so far? Everybody good with that? We got 4 boxes. As soon as you get 4, what do? You multiply. Remember, the front 2, you just multiply. Now, you might be thinking, wait a minute, sir, wait. We got to do something with, well, I guess you're not thinking, there's no other numbers, huh? Yeah, anyway, so let's just go. Let's do those front 2. So those front 2, this is going to be 42 times X, and this is going to be 56 times X minus 0.5. You can distribute that now or later or whatever. It doesn't really matter. Okay, but now, that's all good. I got my 6 boxes. But are there any other numbers I haven't used? No, I've used all the numbers, haven't I? Well, then what am I going to do now? What do you do? We got to do something with that 42x. I'm being kind of sloppy here. We've got to do something with that 42x and with that 56x minus 0.5, don't we? What are we going to do with them? They didn't give us like a total distance we can add up to equal or anything. What can we do? What do you think? Sticking equals in between? Yeah, that's the right answer. Why? Why? Why are they equal? Why would they be equal? Because what? Good job. Yeah, those are distance boxes, aren't they? Remember where they come from? Those come under the letter D. Those are distances. What do you know about the distance if a car makes a trip and then says, hey, if I go faster, I'll get there quicker. Does the distance change? Of course not. the two distances are equal. It's the same two towns. It's the same trip. It's just doing it faster, huh? So the distances have to be equal, don't they? Does that make sense? Let me give you a big hint, guys. If they don't give you another number, it's always equals. You know, you don't have to think so hard about everything. If there's, when you get down to the last, you got these last two boxes, and you're like, what do I do? If there's another number, well then, yeah, you're going to add it to be that number. If there's not another number, you set them equal. That's how they always set these up, if you don't want to think it all out every time. So, okay, multiply that through then. So let's solve this. 56x minus that 28. What do you do now how do you solve for x when you got it on both sides? There's equal sign, left side, right side. Just get rid of one of them, right? I think it would be easier just to get rid of this one and put it all on one side like that. So then we get, what is that, minus, is that 14? Yeah, 14x minus 28. We good to there so far? Last step. Divide by minus 14. So x is 2 positives. Nice it came out positive. We don't want negative. 2 negatives, positive 2. Positive 2. We got it. The answer's 2. Oh, yeah, and I even said the answer's 2 there, right? All right. All right. Alvin paddled. I'm just going to leave that. I'm not going to write it all out. Alvin paddled 2 hours, blah, blah, blah. Return trip, same current. Yeah, the difference here, the trick on this one is you got a current going on. So this is where it's put. If you took Math 201, you did some of these. You didn't do these kind probably. This is going to push us a little further. When on a travel problem, you know what happens if you have a current. Say you can paddle. All right, let me just make up some numbers. Suppose you can paddle 5 miles an hour, and suppose the current is going at 3 miles an hour. Oops, miles per hour. Let's just make up some numbers. If you can paddle with your paddle at 5 miles an hour, and the current of a river is moving at 3, when you go with the current, downstream with the current, how fast are you going to go? You're going to go 8, right? You're going to add them up. It's going to be 8. You're doing 5, river's moving 3, you're going to go 8. That's right. When you turn around and go upstream against the current, against it, you turn around, you're paddling, the river's coming against you, going uphill, upstream. How fast are you going to go? 2. You're going to subtract them, right? That 3 coming against you is going to slow you down 3. You're only going to be able to make it at 2 miles an hour, right? So the point in that is you take your paddle speed and up here you add the current, and down here you subtract the current when you're against it. We all know that. Well, that's what you're going to have to put in the dirt table, in the distance rate time table. That's going to go in the middle rate boxes. So let's do that. So there's only one of these. Distance, rate, time. Same 6 boxes. But in the middle 2 boxes, this problem is different. That's the battle in math test, right? A lot of the battle is identification. So let me help you with identification. When you see this one, if this one is on the next exam, I don't even remember exactly, but if we see it in the homework, you want to think, okay, this one's different because there's a current. That's what's different. They might give you a plane in the wind. Same effect, right? When the plane is with the wind, that adds to its speed. When it turns around and flies against the wind, that subtracts from its speed, right? So a boat in the river or a plane in the wind, same thing, you got a current going on. So what does that mean? What do you do differently? Right away in the middle 2, this is speed, isn't it? Which is rate. In the middle 2 rate boxes, you got to go paddle speed plus current and paddle speed minus current. The speed is more complex. It's made out of paddle speed plus current speed when you're what? With the current, and it's minus when you're against it. So those are the 2 situations. Instead of card number 1 and card number 2 or whatever, it's with and against. This is always how you set up a current problem, a travel current problem. Everybody see that? The rest is mostly the same. That's the difference right there. So let's take it from there. Alvin paddled 2 hours with the current. So 2 hours, where's that going to go? 2 hours with the current. That's the time with. 5 mile or kilometer per hour, same thing, current. 5 kilometer per hour current. That's the C. It's 5. They're giving me this. They're just handing it to me. They're telling me the current is 5. So it becomes 5 plus P plus 5 and P minus 5. Current has been replaced by 5. They gave it to me. The return trip against the same current took how long? Can you read it there?
7 hours.
7 hours. That's the time against the return trip. It takes longer going against the current. All right, we got the right 4 boxes. What do we always do to get the left 2 boxes? Multiply, right? 2 times P plus 5 and 7 times P minus 5. Okay, good. And are there any other numbers anywhere on this problem? Nope. So what am I going to do with my 2 boxes? Set them equal. And it's because the distances are the same. It's the same trip. It's just downstream and upstream between the 2 points on the river. Same distance, right? The distances are equal. Then you just solve. Dot, dot, dot. Can I just set up? Can I take 1 minute and set up one of those other tricky ones and then let you go? So is that good? Everybody see on that? I want to set up one of those other ones that can trick you and let you go. So I'll leave that one. They put it at number 2. So number 2. Snooker's lumber, blah, 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 blah. This is a money problem. Let me just give you the thing. There's the first equation. Remember, we always do no money. Second equation, we do all money. They're talking about lumber or plywood. And so you go lumber plus plywood, like usual, is, I don't know, what is it? Oh, you don't. That's the trick right there. Yeah, they say this tricky line. They say twice as many plywood as lumber. So that means lumber is twice plywood. That's the trick. Their first equation's a trick. The second is normal. $30 for lumber, that's 30L, and 50 for plywood, that's 50P, just like usual. Put the money in there. Didn't get any better there. And total money, $13,260. There we go. It's just like that. Then you just grab that and you plug it in for L right there. And the rest is easy. All right, so we did it. We made it through all that. So I'm going to write on the board what our homework is, but I have no pen anywhere. I guess I forgot my pen. So anyway, we finished 3-4, 3-3, 3-2, 3-4. We finished all those. Those are due next time. Monday. Have a good weekend, I guess, and we'll see you till Monday. Hang on if you got questions. Otherwise, I'll see you. Good use of time.